Hi Arnim, welcome to the HP Barcelona site.
Yeah, thanks Clara. Always a pleasure being here. Always love it to travel to Barcelona. Really great.
It's good to have you here in this building. I don't know if you know, but this building was built in the 14th century, and the HP Barcelona campus that we are right now is the biggest R&D center in Europe. So it's great to actually be having this conversation in this building.
Yeah, it's always, as mentioned, always a pleasure to be here. And of course with this, that's great, really. Slightly older than we are, no? And also older than our relationship.
Yeah, slightly, which it kind of brings us to next year. We will be celebrating this 10th year anniversary, and being in this building, it kind of remembers or reminds me of the beginnings of the relationship, which dates back from 2016.
Yeah, it's already 10 years. Really impressive. And of course, it's interesting to somehow remember what we have achieved, no, in these 10 years. Great relationship, a lot of topics, no?
We started with the first PA12 for MJF, which back then we started mostly with prototyping, but if we look at the applications that we have right now, it's pretty impressive, right?
Yeah, the change from prototyping to industrial, that was a big topic, no, that we were discussing, and finally we achieved a lot, no?
Yeah, at the beginning, these were the customers that we were looking for. Customers that really wanted to validate the material for final part production in automotive, in industrial applications. There weren't a lot back then, but more and more we're finding applications like the Ocado bot, for example, that is really showing the potential of the technology when you use for like redesign, lightweighting, and things like that.
Yeah, and going back also on the materials level, of course, we started. The first materials already were really good in refresh rate, no? I think that was a major change in the industry.
Yeah, not a lot of people had sustainability in the top of their minds 10 years ago. They do have it now, but I think very early on we took that no waste or minimal waste strategy, and we tried to develop these materials with the highest refresh ratios in the market, which not only from a sustainability standpoint, but also from a cost per part standpoint, were very effective in that regard.
And I think it's still the industry standard, no, that you're developing, so or that we have together what we developed. So it was always, I think, looking back, always the combination between printers and material. I think that's really the magic of it. And I think that's also one of the most important parts of our relationship, no? Very open conversation about all the technical topics. So that is good, I think.
I think that's where the success of the relationship comes. We are experts in the fusing science, in the printing process. You are experts on the material chemistry. But as you said, it's always about the interaction of the material and the printing process. And the fact that we are so open when we develop a new material, I think that's what has allowed us to develop materials or disruptive innovations like the flame retardant material, for example.
Yeah, that's the newest one. Yeah, interesting. And of course, when looking back on these 10 years, there are a lot of interesting applications. No, we were looking for sports, for industrial. Now drones is a big topic. Also robotics. That was really impressive to see. For us as a chemical company, only supplying the raw materials, but then having the connection to the end application, that's really great.
Yeah, and it really speaks to the benefits of additive and of MJF. When you take a material that has strong enough mechanical properties in all directions, you're able to remove as much material as possible. Then you come up with applications like you were mentioning, no? Robotics, end of arm tooling. As much weight as you remove, the more accurate the robots are, the faster that they can go, and that's like real value for customers.
And also looking back the 10 years, of course, at the beginning, sustainability was not a really big topic. No, of course, we started, but it was more TCO driven to have materials that have a better refresh rate and combined with your process. But now it's turning, no? So the sustainability is something we are talking every day about, no? Really important.
Yeah, we see customers every day from different industries. We have eyewear, for example, large companies, they more and more have sustainability at the top of their minds. And that's why it was very important for us that we could partner with you on driving the carbon footprint of an MJF printed part down. And the fact that you introduced the use of renewable energies, the use of biomethane, for us it was a huge impact.
Yeah, and of course we have to say that HP in that regard, they are industry, the one who has, you were the first ones who have applied these materials. So all the materials supplied by Evonik for MJF, they are reduced footprint materials. So that was really a big change. And of course there are new things that we are talking about, no, or thinking about. Different feedstocks, that could be a topic for future. Circularity, we have some nice examples also for circularity where we are starting at. We have industrial applications, no, where we are thinking about circularity. So where we supply the material to HP, like always, there will be some industrial processes to produce parts, and then afterwards, if there is some waste or waste parts, we take them back. And of course, we try to introduce them again into our process, be it on a low level, on a mechanical recycling, or on the highest level, which would mean then that we produce again a 3D printing powder out of these parts or out of the waste powder. So that is really, then we have a circle, we have closed the loop for these applications, which would be great.
Yeah,
I think makes sense.
Exactly. We started with the high refresh, having in mind no waste, then the circularity. And I remember when we were talking about how to drive down the carbon footprint of a printed part. And when we calculated it, basically what we saw was the two biggest drivers were the production of the polymer itself, and then the energy that we put in the printing process. From our side, we always try to, as we look at future technologies, how we can reduce the energy that we put in the printing process. From the material, from the production of the material side, the fact that we were able to reduce by half by using renewable energy and biomethane, that's something that has had a tremendous impact in our customers. When we go to customers now and we calculate basically the carbon footprint of a printed part, we are now 30% below what we were in the past. And I think if we really care about sustainability, it's important to drive that for our customers in all industries that we have. And taking that, that strategy and now applying it to all of the future materials like the FR now also being produced with renewable energy, that's a move that no one else in the industry has made. And I think we've shown our belief for sustainability by making that move together.
Yeah, definitely. And we are committed to that. So I think that's also, as you mentioned, future. So besides the sustainability topic where we are really engaged in both companies, there are some other things to do now. What is next?
We see two segments today that are growing a lot. One of them is orthotics and prosthetics. The reason why additive is a perfect fit for that application is because all of those devices are personalized. But you also need a technology and a material that are able to print thin parts like an insole and deliver strong mechanical properties because they will be under constant dynamic stress. The other market that is growing a lot lately as well is drones. The big advantage of using additive technology into the drones application is basically lightweighting. The more weight you can remove from the structure of the drone, the more batteries you can put in, and then you're basically extending the range, or you can put more payload into the drone. In that application, the key is to have a printing technology that is able to print very thin structures, but you also need a material that at those very thin structures is able to deliver strong enough mechanical properties to sustain basically a flying drone. And in that case, in both cases, both for orthotics and prosthetics and for drones, the combination of MJF technology and PA12 is a winning combination that is basically delivering big successes into the market.
So I think we're at the end of our conversation, Clara. It was always a pleasure to come here to Barcelona. Really, thanks a lot for all the insights and for that nice discussion. It was great.
Thanks always for coming to the site. You're always invited. We always have very good discussions face-to-face. Innovation is basically driven face-to-face. So always invited to come, and very happy to keep collaborating together with you.
Thanks a lot.
Thanks.
Evonik, leading beyond chemistry.